course, while studying, most attractive thing was actually the dynamics of the waves. And naturally, it ends up with the quantum mechanical phenomenon, what's happening at the maybe of the order of maybe 100 nanometers to down to maybe
1 picometer.
Beyond that, I am still doubtful whether the equations hold good, though we predict with the same scale the bosons and the Nobel Prizes awarded. When it comes to the last 6 months back or 8 months back, things are changing. The perceptions need to change in 21st century. How fundamental is the fundamental particle we are searching for? A union and transformation of a set of energy into an existence. Does it make fundamental particle? I saw some of them taken down and then further pursuing. I was in correspondence with them for some time, but I can't devote my full time to that. As a rationalist, these are some of the fascinating field which I am looking into. I was telling Professor that usually what I do. Today morning I was trying to solve a third order differential equation. It fascinates me the way in which it diverges and the way in which it is getting confined, having a particular solution within the framework of a region. So physics is always the fascinating one, though the money was paid to me by computing and then computer science and computer engineering. So with this small introduction about my interests and which motivates me, I get into the topic which I would like to talk to you today, the edge of the art, or the state of the art, where the computing is actually getting proliferated. You might have heard enough about the architecture of the cloud and how people are using the cloud, and today I will be talking to you that how the institutions can migrate, how they can model by themselves so that they are not bound by the institutionalized computing like I will have a supercomputer, I will have the storage network, I will have various other facilities and the human resource required to maintain a large computing edifice to support my activities in the institution. Or rather, you say in a company, we call it as enterprise environment. So the enterprise environment or institutional environment where we had the culture of investing large amount of money, maybe 500 million or even 1 billion, to institutionalize my computing and transferring my business process into applications and then porting these applications across various versions of the institutional computing or the enterprise computing what we have. So you might have seen in your university itself the way in which computing systems would have swept for the last 30 years. It must be actually the low frequency things would have happened in a university environment, but it happens with an incredible speed and pace in the enterprise environment, because enterprises are in the business competition, and the profit over profit or the sustenance of the profit is one of the key factors which enables them to perform. So the processing of the data by which they are able to coordinate and successfully lead the business is a great a value of high importance, and hence they have to be competitive only if they are able to compute things, or if they are able to process the data effectively, competitively, and with the current speed what's prevailing in the market today. So if their competitor is having a better computing systems and a better analysis of the consumers and the market responses and the economic drifts and the production sequences, raw material availability, supply chain management, all sorts of things associated with the enterprise existence. If things are changing incredibly fast and they are pretty slow in comprehending things, it affects them. So enterprise computing is always seeking the best of the computing all the time. And the culture of the past is that I have to update the computing systems every 2 years, 3 years, 5 years, depending on the way in which you are actually modeling the IT infrastructure. So this has put a large load on them, and the technology comes with its own evolutionary scheme. One of the schemes which is actually aiding the enterprise arena or large institutional arena is the computing cloud or the cloud computing techniques. You can see here actually, you have all the gadgets around you, or the company has got its own departments, and then the computing is the complete paradigm where the data is getting created, whether it is accounts, purchase, production, or the marketing, or the supply chain management systems which are taking out the product out and then bringing the products in. So all these things are generating large amount of data, and all this data need to be processed, and we have to have large computing systems for that. When it comes to society today, it is completely digital, society is under the digital influence. You have got every type of gadgets you have seen. All these things are getting integrated, and then enterprise is on the left side, which has got the database, the application servers, and it's on differential environments where a large amount of integration of data, processing of data, result generation and dissemination is taking place. So all these things together, when I couple it, I will be able to perform much better in a distributed enterprise environment or in a localized environment with the institutionalized computing which was prevailing there, or transfer my computing to readily available resources in any part of the world. There the cloud comes. When you are looking at the sky, you are able to see the cloud. Can you say that you are the only person seeing the cloud? No. Anybody wants to see the cloud, they can look into the sky and they have got an access, optical access. So the cloud computing also, we would like to bring it into the arena of computing, or we have already brought it, so that the clients, whoever wants to cling on to that and do a computational work, they will be able to attach and they will be able to do. The same way you have done, millions of people will be able to club to that and they will be able to do the computing and they can go back. So some people may have why it is called the cloud. This is the concept with which we started calling. This facility is a cloud, you can access it from anywhere. And you can do the computation and you can leave the place. Once you are looking at the cloud, your eyes are not going to be locked with that. It's not mandatory to look at the cloud all the time. So, when you want to look at it, and the rest of the time you leave it. So, this is what actually the emergence of the cloud has happened. The growth and diversification in the complete information technology field, it is amazing. So, it has taken different violent turns many of the time unexpectedly. Because the dynamics with which the processing capabilities, every year it doubles, probably 6 months it is doubling these days. So the growth and diversification of the computing technology, several milestones are there, so to say, to go a little bit clear. So the mainframes, the trusted ones, you have CPU to PCs, PC to notebooks, netbooks. Finally, from all network, the systems connected to high resources, the cloud computing is. So, the cloud computing currently delivers hosted services. What is hosted services? That means my computing facility will be available at a remote place, and I will be able to access it, make use of it, and I can relieve it so that it goes away. So it's a hosted service, and based on a pay-as-you-go pattern. So if I'm using something, it's like actually you hiring a taxi. You are going to use it for 1 hour, you pay for that, and afterwards the car goes away. So similarly, pay-as-you-go pattern, you will be able to make use of the computing. You don't have to buy it and keep it along with you in any of the offices or in any of the places where you want it to be. So it provides reconfigurable. This is the point you are getting. Earlier when you buy, you will be able to get only one computer. Today, it is reconfigurable. It is upgradable. So even if I am doing a computation now with X power, I can upgrade it to 2X at the same time or the next moment. And it is this possible. I don't want 2X, I want only half X. I can dispose 1.5X from 2 to half. So computing resources for any client who wants to avail the services at a cost. So services at a cost is the offer of the cloud. You want to ask a question?
Yes. The safety is the main issue if you use the cloud computing.
Pardon me?
The safety.
Safety, you are talking about security. We will be coming to the slide there. It's a part of the talk. So, cloud as a service is the theme what we are discussing. When the resources are accessible with a request structure, how the resources are available. When I have a computational need today, and I may request what are the associated resources there, R1, R2, R3, R4, including your printer or your plotter or things like that could be done. But it could be done at your end, but the transformations will be done and the file will be down to your peripherals, which is in your room. So you will be clustering the processors, you will be actually adapting the storage network, the storage area SAN, storage area network. You will be actually plugging out and in the memory what is required for your computational capabilities. So it is reconfigurable, upgradable, and it is disposable, and variety of services available in this architecture that they are called usually SaaS, PaaS, and then software as a service, platform as a service, infrastructure as a service. We will look into the patterns later. The deployment can be private cloud. So a cloud can be made privately. Maybe Walmart will have its own private cloud. You know, Amazon has got its own private cloud, and it is supplying to the other people also. So HP, Amazon, there are so many companies which are actually providing the cloud for others. Public cloud. A set of people can create a cloud and then make it available to the public crowd, or maybe a wide variety of companies. In those cases, we will call it as public cloud. And then community cloud. A set of companies cling together and they make a cloud for them and they share in between them, but they don't give to others. It becomes a community cloud for that community alone. Then hybrid cloud. I make large cloud, and a part of that I give for the public to access, and the other part I am using it reserved. So I can say it's a hybrid cloud. Enterprises find this transgenic computing environment as a green field for migration. So enterprises across the world, they want to have the best computing atmosphere all the time. Can they continuously invest upon one edifice over the other like that, spend the money, and then it can be used only for 3 years or 4 years because of the odd seasons? So can they move in that line, or they can invest in on-demand computing, what they can avail from the cloud computing architecture and cloud computing approaches? Which will they go? Naturally, this transgenic or the transforming one across different technologies getting integrated. So they will definitely move into this computing environment, and its advantages to them too. And third, enterprise computing, when we are looking at it, enterprise or institutional computing term compounds to business and scientific computing products. So I'm working on a completely a business institution like any of the commercial institutions or commercial or the companies across the world. At the same time, there are other computing demands where actually social level systems like government, or must be scientific institutions like maybe the large-scale laboratories which are actually pursuing the scientific issues. So they all have got an application environment which could be transferred to the cloud, and they can use it. And they can use it for mission-critical transaction systems, they can use it for the databases, and then multi-unit based process integration software. So in a company you have got, you know, different business aspects coming out of it. That's actually the purchase activities, or the production activities, or the sales activities, or any of those multiple functions. If it is another institution, it could be actually the controlling of the public funds and controlling of the administrative systems, like the governments can make use of it. So the movement of the enterprise or the institutions towards cloud computing is quite natural, and it's happening today. Enterprises need robust technologies and development environment to create enterprise software. So enterprise software is actually the mapping of the business process of an institution into the software, and software starts working, the institutions becomes dynamic, active, and it's able to respond. And how did it all come through? We will have a look at it. And the traditional data centers were there, most of them housing actually your web spaces and your databases and your large-scale transactional informations. Can be actually an insurance corporation, and it could be a stock exchange system, or it could be a governmental database. All these things were actually supported, and large-scale web operations. They were all supported by the traditional data center, but of late, for the last 10 years, they got transformed into a virtual data center, which is actually all the resources are behind the hypervisor or the virtualizer, and all the interfaces we have actually generalized, and it is getting connected to the resources like the processors, the memory, and the storage area network. All these resources or the communication edifice, all these things are actually getting coupled not directly through actually a virtualizer or a hypervisor layer. This is actually a layer of the software, and we will have a touch on that too in the coming slides. Initial cloud formation from data centers look like this. So, if you want to know a little bit about the definition of the computing, cloud computing, we have the definition here. Actually, cloud computing is a model for enabling the convenient on-demand network access to a shared pool of configurable computing resources. This is actually sufficient. And of course, the explanation is there. That can be rapidly provisioned. Rapidly provisioned means I am asking for a teraflop now. Maybe the next instant I will go for maybe 10 teraflops into maybe a petaflop afterwards tomorrow. So it should be able to provide me the provisioning capabilities, scalability. And the cloud model promotes availability also at any time, maybe in the midnight or in the midday. If I go, I must be able to get all the cloud, all the computing capabilities on demand. So some of the essential characteristics of them we can look into. And the main characteristic when we look into, it remains to be on-demand self-service. As I said, it's an on-demand computing environment. The model is an on-demand one. When the demand comes, I will be provisioning the memory and the processor clusters and the storage network all together, take a bundle and give to them. And they have the computing environment. So the computer can expand, contract, and on demand it can reconfigure and then do that. For that we require actually the resource pooling. All the resources in the center or the cloud, under the cloud umbrella, we should be able to pool it together and probably disintegrate it and integrate it on demand purpose. The capability to pool things. Rapid elasticity. If I'm able to pool, how would I integrate them into a homogeneous system responding to my computing requests? So that calls for rapid elasticity, by which the memory panels may be M11 to Mn, the memory part M into N, a matrix if we take. Same way, if it is actually closed, matched matrix in which we are arranging the processors, it can be actually 1 million processors. You are using only one or two, maybe it's a quad core, means you have got four units of the processor working in a 4 parts of a square. That's what the quad processors are giving you. But here I am going for actually 10,000 processors. So all these processors I will be able to make use of it by picking out P11, P27, P45. Like this algorithms are there. We will be able to pick up and then create a probably 128 processors from the map of the processors, and then I will be able to pick up memories of the order of few thousands of gigabytes. Okay, and then I will be able to get a beta storage from the storage area network. Take some part from there, a set of processors from here, set of memory from there. I collapse it into a single unit and trigger it with hypervisor. It becomes a large computer and it's made available to you. So rapid elasticity of making it big, making it small, and then providing all the resources required for it. And the measured services, when I am accessing it, the computer systems or the cloud management systems, you can see some of my papers in the measured services and the resource pooling. Resource pooling, one of the critical paper of 2009 is from me, which is emulated by many companies now. So the measured services, you can control and optimize the resources using metering capability. That means about 10,000 people are accessing. Each one I will meter such a way that how much time and how much resource. Time and resource 1 to resource n. And the delta t, if I take, I get the picture of how much I am getting used from the cloud. So there will be a mapping algorithm by which I will be able to compute the cost of it, and then structured security. I should have extreme security or moderate security or a public security. Very often programs, if it is run, I need to give only certain security. It's not the extreme security. So a structured level of security for the high security to medium security to lower security computations. So that's a requirement which we are able to characterize in the cloud. So the service models are actually, as I spoke to you in the past, cloud infrastructure as a service, cloud platform as a service. Platform means I will be offering the a raw computing system, but you have to create all the applications, you have to create the supporting software by which it looks like a raw computer, you can play with it, and it can be used for development purpose. And cloud software as a service. Software as a service means you want to use large-scale database systems or large-scale business processing systems, maybe large-scale data analytics, or you want to go into big data systems and its capabilities. You have got software which is readily available there. You prepare your data, submit it to the software, software will compute the vectors what you want out of it and will be delivered back to you. So you don't buy the software at all. You pay for the time. You pay for the time of use of the software itself. Today, that's not the case. When Microsoft is selling, he's taking the money for the software all on a full shot. And he's taking the hardware cost also in the beginning itself, whether you use it or not. So the world is changing. We are becoming cost optimized, we are becoming more intelligent, and we are becoming actually more purpose-driven. So these paradigms actually changing the technology, changing the industry, changing the process of thought of the human being itself. Well, deployment models are many which we have spoken actually a few minutes back. It can be a private cloud solely for the company. And it can be a community cloud which is meant for actually a set of people that will serve the community. And it can be a public cloud where people access and store their things and retrieve it back and forth, like a public transport system. And a hybrid thing. Hybrid thing can be created by public people and by private people joining together and selling it for success of the break-even point of the commercial mode. So the enterprise systems, definitely we have to look into how they migrate it. So the advances in computing which actually makes you to reach the enterprise performance. An enterprise system provides proper abstraction of the various activities. If it is a university, students' admission, the management of the courses, and the delivery of the classes, and many other things, and the human resource management. So all these functions together in abstraction, it makes the IT of the university. So similarly for the companies, there are different types of things that you have to migrate into the computer. And traditionally these ecosystems were centered in-house infrastructure. If a company is there, Aramco will definitely build a large amount of computers in their custody and they are making it. Today, they have got the provision to go into the cloud and then do it. Whether they can make their private cloud and use it or not, it is up to the company to decide. Mostly it's called for organization-specific infrastructure and software architecture. So we will look into that. Every time, whole system was framed into enterprise architecture in the past. Now, when you want to move to enterprise architecture, definitely enterprise architecture is the outer cover. It has got a segment architecture and a solution architecture, and every architecture has got a scope, detail, impact, and audience. And the audience involved in this are three types of audience. And they are the stakeholders and the business owners and the users and developers. So depending on that, these values, what are the impacts of the enterprise architecture and its lower level of segment architecture, it is shown by bit of the graph. And to transfer your business model, your company is large, it's a distributed company across the continents, and you have to translate the whole thing into an enterprise software. It's a basic problem of the enterprise software. So you can do it with the Sackman framework, or there are a few other frameworks available. It's only for giving a picture of how things are getting transformed. So this enterprise transformational tool or the system and methodology, you can apply and you can do it. Like data, a function, network, people, time, motivation. And these things are actually the parameters which will transform into the level of scope, enterprise model, system model, technology model, and detailed representations and then functioning of the enterprise we research. Okay. So similar to this, you can go for the TAGAF and it's an architectural development method, ADM, and you can see that this is a different model of approaching the system, how to make it. Here you can see one model and another model there. So what does it do? It is mapping the current operations, business operations into the computer models, actually. And when you are going with the enterprise computing by having your own computing systems in-house, what are the disadvantages and what are the advantages? So where do we get the advancement? In-house control on software is the advantage people claim, but how far it is true, we are yet to see actually in the better atmosphere which is coming up, or at the wake of the chances of porting it with lesser cost. So high availability of the corrections and availability of the corrections, business upgradations possible very easily. Everything is under your custody means you can be lazy. You can do it at any time you want, and you can do it at any scale you want, but the net result of profit and loss, it is actually totally on you. And enterprise computing is squarely facing challenges at the same time. What happens is the material what I buy today, or the practice, or the software what I develop today may not be relevant tomorrow. So that is actually one of the biggest problems. Initial huge investment in the infrastructure. For 3 years, if I'm investing my $250 million loan, or either in the software side or on the hardware side. Specific platform-based software development and its upgradation, reconfigurations. Now every day operating systems are changing, techniques are changing, hardware is changing. So getting involved with that is a big headache, and there are management schemes for it, but it goes. So maintenance of the real and virtual resources of software device as well as hardware device, it is actually a big problem. And maintaining global communications and system coherence. I have companies, my company is actually in Japan, and maybe in Singapore, in India, and maybe in Saudi Arabia, to Europe, to American continent. So how do I keep the coherence of things? I have to have my own systems and get it connected. It's very expensive. So do we have to have all these challenges borne by us continuously? There's no need. All these connectivity problems and then the reconfiguration demands, we can hand it over to generalized units and systems. That's what cloud enterprises can give. Changing the game for mission critical enterprise infrastructure through cloud. This is what we were speaking, and this is one of the model. It was almost first suggested by me in IEEE conference in 2009, P112 PEMN, and this is the memory model, and this is actually the storage model, and these things can be played by picking and placing it into configurations. Allocation of computing resources when and where they are needed. Manage associated PMS as a multi-talent format, ability of the cloud architecture effectively schedule virtual memory systems actually, and PMS matrix. PMS matrix is process memory storage matrix. There is a big theory of it and then later things. And how does an enterprise cloud structure look like? It has got a network switching and a virtual set of firewalls and hardware load balancing systems and the whole processing clusters and the storage clusters and the memory clusters. And then the global data centers are actually getting supported by this, and the network services will be actually connecting the cloud to cloud, which we will have a diagram later, how cloud to cloud is getting connected. So enterprise cloud security, there was a question from that side. So enterprise cloud must provide multiple security standards, not only one. If it is a standalone computer, you are not attacked by the net itself. So the security standards are different in a standalone computing system, whereas in a distributed computing system, security standards are slightly different. So it has to have different types of security levels, different types of security issues translated into multi-layer format and embedded into the architecture of the cloud. So multi-layer approach to delivering security services enables the customers to purchase appropriate risk reduction services. So when I am getting into a contract for running my software, I will be definitely looking into the risk reduction services, what I require, and I am ready to pay for that. So multi-layer security services can be delivered in the cloud to help defend your websites, your applications, your data from malicious attacks. Many types of security issues can be sorted out, but it goes depending on what layer you are going to hire. Enterprise cloud architecture is actually mainly, as I was telling, it depends on some of these methodological issues like resource pools, burst mode operation. Resource pools already we have discussed a little bit of them, and you can read there too. And the burst mode operation may be an interest to you. You are computing with 1 teraflop now, and maybe after 3 hours, maybe the election results I have to release. So what happens is that from the whole world, people will be coming to my computing system, and my efficiency has to be maybe 100 times or 1,000 times better than what I'm doing at this hour. So what you can do, you have to go for a burst mode operation and then come down. So maybe a hurricane coming, the requirement to the environmental ministry or maybe the weatherman, it will be going so high, so that a burst mode operation also must be possible, which can be provided by pulling more P and M and S from the cloud infrastructure. So virtualized machines, of course, without virtualized machine, there is no cloud possible these days. So complete reliability and high security it must be able to offer, and it is available today, or it is in the best of the best development transitions. So role-based security. So what type of security you want to give? So you can define, you can set, define, and revoke user roles like any other enterprise computing you are doing within the walls of your company. It can be done, and it can be extended to the cloud computing environment too. High performance storage is there, isn't it? Storage, SAN, storage in the network, which has been transformed into much higher intelligence, which could be coupled and upgraded with the processor's memory of the software, the cloud, and intuitive web-based control. Now, I have actually acquired a portion of the cloud and I am computing from here. So I must have an intelligent controlling system coming on an ordinary computer, but this is like a supercomputer. So I'm getting connected there. My computing capabilities are at teraflops or petaflops with petabytes capabilities of the data, and heavy resource capability in software. I'm doing it. So at the same time, I must have the full control here. Today it's possible. And end-to-end security from my desktop to the cloud and then coming back. It is end-to-end security I should be able to provide. And several security services are in operation, like firewall, intrusion controls, actually logging, and then encryption services, and many things you can see. And then how to deal with the incidents and then management of the incidents. All these things come to the aspects of security. Enterprise class features will be offered there, enterprise agility, enterprise class resources, and enterprise class control. These things also we can transplant into the cloud, and the computation improves tremendously, and it becomes incredibly performant. The liberty and cost reduction are the main attraction for the transition. The whole computing is arriving at enterprise desktops as a service, and a service on demand. That's the point. There are various avatars of it. We have already talked about it, and they can become mixed actually. Already we have talked about SaaS, PaaS, and then IaaS. So it can be combined in different formats. What you see here, and SaaS plus PaaS and SaaS plus IaaS, all these three things together. So these are some of the formats in which you can hire the systems and you can do it. And when you want to move it, you have to have certain models in your mind. Cloud service management, how do they achieve it? So you have the cloud consumers here, and the cloud brokers here. They will be actually giving or provisioning your services. So business support, provisioning configuration, and then the portability and interoperability, which is getting managed in 3 channels. This is one model, and you can see another model of the service. Service developers will be there. They will be interacting with the distributed systems, and they will be going for the creation of the platforms and distributed service delivery platform, which will be giving the user services out. And it's all layered architecture and compute virtualization, and then and the network virtualization and the storage network virtualization. These 3 things actually making all these things to work for several users, which you are seeing there. And more sophisticated engineering has come. These are all in the virtual world. The sophistication with which we are dealing actually. Now look at this. Actually the infrastructure services, cloud services, you can see. So they are actually different types of services we agree upon, And you can see here the user management, storage management, and billing management for which people are using, and scheduling, workflow, all these things are actually systematically managed, and this forms the application lifecycle management. And when we want actually many kind of cloud services to be integrated, you can have a central entity and you can have a star architecture. Cloud A, Cloud B, and Cloud C getting in a star configuration integrated. I can have a P2P, peer-to-peer communication system, which will be emulated in the cloud. So computational exchange can take place between this. And here you can go for a cloud bunch, multi-cloud gateway. So one gateway will be taken from the whole and then supplying the output. And here you can see multi-cloud integral library and cloud API. So it is pluggable, the services of the 3 or 4 or 5 clouds. A service I can integrate, I can do it with it. And issues and challenges. There are issues and challenges for the institution to move on to the cloud computing. Standards and common interfaces for global clouding. It's a problem today. Well-defined standards may not be there, but all people will migrate, or all people will start using the cloud in the same way. So data management and governance, and service management and governance, product and process control, system reliability, visibility and availability, information security, process security, community. You cannot easily compare because there are no good standards which have come up. We have to work for it, and the scientific community will do it soon. Let's hope. And the transitions of the enterprise to cloud, few other aspects are enterprise architecture provides high-level corporate view of the enterprise, transferring it to external cloud. It requires actually think. People are afraid. When my computer systems are within the company, I can put any data. When I'm putting my data into a remote place, governed by somebody else, what is going to happen? That sort of feelings are there. But these are all higher grade systems which is managed automatically. And faith is there, we can find out who is doing what, all facilities are there. So establish clear connection between the different enterprise architectural features and the cloud. We can emulate the whole enterprise into that. So the business applications, data, technical architecture, all these things work together to move. So what is the message? For large institutions, whether it is enterprise or institutions of any other kind, move from desktop and occupy teraflop computing power with petabytes storage and big data, using already proven software and already proven edifices, already proven infrastructure schemes and methodologies. That's what gives incredible computing power at your fingertip. You can't imagine to have actually teraflops or the petaflops within a split second on your desktop. It was not possible. Today it is possible. And all these things have to happen to you all in days, not in weeks or not in months or not in years as it was in the past. I hope I communicated to you the precise model with which the transitions are taking place, and thank you very much. If you have any questions, I'm delighted to answer those things. Yes?
Yeah, quite often you may not be able to connect to the cloud. In that case, is it possible that you borrow some software, for example, for some time you do your calculation in your own platform? Is there any possibility like that?
Of
borrowing something?
Yeah, actually it's a borrowing.
Because you don't do, say you want to use some software.
You don't have network.
You don't have the network. Third world country syndrome, we say. We ensure 200% availability of the network through SDN, where I am the committee member in IEEE for defining. So we want to ensure that the channels are not actually privatized or single entity channels. If my link is not there from Japan to US, and I will be going through multiple channels through Asia. So these things are coming up. So if your wire is not connected inside this computer, same paradigm is existing, but we have overcome in 1980s and 1990s. So same thing across the world. We are on the angle. Maybe in some of the remote places of the world, it may happen continuously. Then your cloud does not have much meaning. We ensure 100% or 200% availability of the channels and bandwidth to see that teraflop is getting transported across the points.
Yeah, but usually it's not only the connection, also the latency, stuff like that. For example, if you want to download something and it takes really long time, for example, from States to download something from Europe, it takes a really long time. And that's why instead of doing simulations, say in Europe, we just borrow that program, do it everything in States, for example.
Well, that concept is actually, it is maybe pretty, we can't say it is going to be futuristic. It is actually transporting the machine virtually to your desktop. We don't want anything here. Okay, the power will be at the remote place because we can manage it better. So you can't realize, maybe teraflop is already, it's there, there are few chips coming. But petaflops and exascale computing, okay, connecting 6 billion or 7 billion people across the world, everybody is connected to every other person. See the data transport what we are visualizing. So getting something into your computer and doing it, still now it has got the psychological attachment of the previous decade. So until unless you remove that stumbling block, you will continue to think in those domains. We ensure that, when the cloud computing connectivity is given, our pipes are radically different than the old hit and run connectivity we had. We expect the technology to be at the best. Thank you. Yeah.
Okay. Is it the evolved part of this like supercomputer, control from your lab?
Supercomputer?
Yes, for example, for scientific computing.
Yes.
You control supercomputer Los Alamos National Lab from your lab, like you send the data and do the calculation and get it back. Is it evolved part of that?
Yeah, yes, you can. You can have the supercomputer carved out of this and then do your what?
No, I mean, is it exactly what you said? Is kind of evolved part of this, or it's completely different thing? For example,
this is what the beauty of it. If you are visualizing the system to be a supercomputer service to be available from that.
From somewhere,
Yeah, from somewhere. That's why we call it cloud. We do not know from where it is coming. It is possible.
Like Windows 360 or, Office 360, right? So you just use it, save it, and just pay for that?
Yes, exactly. Exactly. You will not know from where it is coming, but you will get the power and you will be satisfied because your computations are ready. Yes. And not only on the desktop, on the palm top, we want it.
Yeah, Dropbox is in my mobile.
Yeah, it's a simple.
No, I mean, it's also a cloud computing.
Which is actually popularizing the feel of cloud. Absolutely correct.
Yeah, I just have two notes. I thought that you mentioned the grid system that first was initiated in CERN and high energy physics. It was the leading scientific project where probably the cloud is taking all the resources are from there. It's been a long time now working, but it is specialized in computation and physics and trying to get all the scientists in the world to contribute to that project, and they have to have all the management, all the software. It was one of the leading programs.
Yeah, the grid computing approach, definitely its reflections you can see here. We have inherited many things from such computing trends, actually. The cluster computing,
or it's the vice versa. Probably the cloud is just a picture of the grid. The second point which I wanted to make, the problem of the competition. Okay, these clouds, they need big systems to control it, and if they control it without international regulations, international fair regulations to keep the room for the competitors and the whole world, we might end up really in a disaster, control of the whole system, rather than, human input for this is probably one of the most difficult problems in this system.
Yeah, absolutely correct. Which I have put in a very subtle way at this point. There is no much standard in the cloud computing. And one person to be compared, one cloud to be compared with the other cloud because of the security differences, access differences, the policy differences. I have put it actually, but this is the real politics of computing.
How about if you are a developer and you are using Amazon platform and you have to go to HP platform? How compatible are you? If you are a developer, yeah.
Compatibility is assured now because we want business. But the practices are different from cloud to cloud.
Okay. So you write some program in Amazon platform.
Oh, it is transparent to you. You won't feel it.
Okay.
Yeah.
So one more question and we will close this session.
Yes, I'm just asking about the problem management. You know, in our system in here, for example, our PC, when we have problem, it just localized. You know, some system might fail due to virus or hardware fail. But when we rely much to the cloud computing like this, when it fails, the effect will be global. So how to overcome this problem?
Oh yes. No, actually, from the paradigm where your thinking process is locked in, we are moving to actually 1 million processors and maybe 10 million clusters of the memory.
So it's not localized.
Yeah. Actually, what is failing, what is not failing, even human being is not available to know actually. When it's failing and that portion of the code or the process will be automatically shifted. You can read some of my papers. It will be shifted to the attachment is dynamic actually. If the attachment is failing, we will not know. The failed one will be eliminated, it moves on to the other. It's like your body and cells.
Okay. Thanks.
Okay, thank you very much.
Thank you. Thank you very much. Thank you very much for inviting me here and those people who are working for that. And it was a pleasure to be here and hope